So last class we were discussing the materials, the properties of the material. A material can be stiff, it can be brittle, it can be malleable, can be ductile, it can be hard. It's a surface phenomena, hard, and it can be tough. So stiff materials, if object is difficult to change the shape or the size or produce we need a greater amount of force to produce a small extension, we call that material as a stiff. For example, I have two graphs. One is like this, A, another one is B, red one is B. Which material is stiff here? The definition of a stiff means we required a greater amount of force to produce a small deformation, a small extension. A or B? The correct answer is A. Why A is stiffer than B? Because you always check the initial slope. You don't bother about what happened afterwards. Afterward, the object become easy to deform. But initially, the beginning, A is difficult to stretch as compared to that of B. So to check the stiffness, you will check the initial slope. So the one which is steeper means that will be stiffer as well. So slope is directly proportional to stiffness. A brittle object and this axis on the graph, what are the axes on the graph? It can be stress or force. Here it is strain or extension. Stress is denoted by sigma, strain is denoted by epsilon. If a small object shows no or very small plastic deformation and breakdown, which object is brittle, A or B? First thing, for object to be brittle, small or no extension or very small, change in the length or size, and then the second one, small force should break. So which object is brittle? So A is brittle. Example of a brittle material, like example, a glass is a brittle material. A biscuit is also a brittle, like you apply a small force and you can break without deforming it too much. Then toughness. So first thing, condition is small change, small extension or change in length. That is the first criteria. And the second thing is the force. Even though A required greater force than B, but you can see B deform more than A. So first thing is small or no plastic deformation, and then the object can break down. Then toughness, tough objects. For tough objects, object can undergo considerable deformation before it break down, or it can absorb greater amount of energy before it break down. So for toughness, you will check the area of the graph. The one which will have a greater area under the graph, that is a tough object. So if you have two graphs, cross means they break down. Which is a tough object, A or B? So B is a tough object because it has large area under the graph. A is having a small area under its graph. Then when it is showing a plastic deformation, the plastic deformation means object will not return back to its same original length, shape or size. We call that as a plastic deformation. So it can be a plastic deformation, it can be a malleable, and it can be a ductile. The difference, if we can hammer, if object deform under compression, we call that as malleable. If object deform under extension, means we apply a force, we draw them into wire, so it is deforming by applying a tensile stress. And here we are applying a compressive stress. So if we apply a compressive stress on the object, we call, and it deformed plastically, like it regained the new shape, but does not return back, it does not regain its original shape and change or into new, we call that as malleable. But if object deform under tensile stress, we call that as ductile. So to know, like from the graph, you cannot say it is ductile or malleable. From the graph, you just have to check the area of the plastic region to show that is a plastic deformation. But exactly to identify whether it is a ductile or malleable, in the question it will be mentioned. Like if I say we have a graph with two materials, stress and strain. This is one. And after this red line is the area of the plastic region for one. For B, this is a graph. And example, this is the red line is representing elastic region, means that object can return back to its same original length, shape or size. That is the elastic region. And if object can deform permanently, that is called plastic region. So when you work out, you will find which one is having a greater plastic region, a greater area. So for B, if I say this one is B and the first one is A, so B is having a large area as compared to that of A. So B is more malleable or ductile as compared to that of A. And specifically whether it is malleable or ductile, it will be mentioned in the question that object deform under compression or object deform under tensile stress. Is it clear the difference between the two? Both show the plastic deformation. Like example, we have like copper we can hammer into shape, and we can draw them into or stretch them into wire or make wire. So copper can deform both ways. So copper is malleable as well as ductile. Yeah, both are the plastic deformation. Plastic deformation means does not return back to the same original length, shape or size. Then hardness. Hardness is a surface phenomena for strength or strong object for strong material, greater force or stress to break the object. It is independent of what kind of deformation. Object may have plastic deformation, may have elastic deformation, any kind of deformation, but you need a greater amount of force to break down the object. Cross means it break down at this point. Which is a strong object? A or B? So B is stronger. Why? Because you will work out from the graph that B need greater force as compared to A. And the maximum stress which is applied on the object, that is called ultimate tensile stress or UTS. So UTS means it is ultimate tensile stress. That is the maximum stress applied on the object. So maximum stress applied on the object, that is known as UTS or ultimate tensile stress. Then hardness. Hardness is a surface phenomena. A hard material, you don't have a graph. It is a surface phenomena. Means if it is difficult to scratch the surface or dent on the surface, what we call that as hard. Like hardness, you don't have a graph for this. You have two material. Example, you have a diamond, which is carbon, arrangement of a carbon, and you have same size of graphite, which is both are allotropes of the carbon. same element, different structural arrangement. And we rub, like example, if we try to, we use say another object, a metal object, and try to rub the surface, which one is easy to scratch or make a dent? If we rub them, so graphite is easy, so graphite is soft, and we can say diamond is a hard. So diamond is the hardest substance known, and hardness is measured in a Mohs scale. You don't have to learn what is the Mohs scale, but like it is in number, like 1, 2, 3, 4. So using a Mohs scale, you can work out the hardness. Is it clear? The properties: stiffness, greater amount of force to produce a small extension; brittle, small or no plastic deformation, object break; malleable, if object can deform under compression; ductile, object plastically deform under tensile stress; hardness, difficult to scratch or dent; tough, object can undergo considerable deformation before breaking; strong, greater force, the force which is required to break, so greater force is needed to break the object, that is called strong. So when we compare the graphs of force and extension, when we compare the graphs force extension and stress strain, so here the slope is equals to k, but here the slope is equals to y, the Young's modulus. The area under the graph represent energy stored, and here the area under the graph will give us energy density. What is how energy is stored in energy densities? If I draw a line here, so it will be half base into height, F into E. And if I draw a line here, that will be half stress into strain, because it is making a triangle, so half stress into strain. The unit of the force is Newton, and the unit of the extension SI unit is meter. Newton meter is equals to joule, and joule is a unit of energy, so that will give us how much energy stored or how much work is done on the spring. If it is loading, how much work is done, and our work done is stored as an internal energy. But what about stress and strain? 1/2 is not, because in terms of unit, so stress is force over area and strain is change in length over original length. 1/2 will not make any contribute to the unit, that's why I'm not considering. So F into delta L divided by A into L. F is a force Newton, length meter, area meter square, length meter. So Newton meter is joule and meter square multiplied by meter, that will be meter cube. So joule is a unit of energy and meter cube is a unit of volume. So how much energy stored per unit volume? So energy stored per unit volume is called energy density. But energy stored in the overall object we can find by force into extension graph or from force extension graph. Is it clear? Why stress strain graph are more useful? Like example, if I have an object and I want to deform this object, either compress or stretch, so I have to apply a force and I have to calculate how much the size increases. And maybe it is a, say, a metal object, like an alloy is there, so alloys are much harder, difficult to deform, so I need a very greater amount of force to extend, so it will be difficult to do this and calculate the total energy we supplied or work done. Instead of that, we can calculate the stress, because when we calculate a stress, the area under the graph, so it is not depending on the size, the length of this line. So when we work out, so stress and strain graph, the area under the graph will give us energy density or energy per unit volume. And using energy per unit volume will multiply by total volume. So we can work out how much energy is stored by the total object. So stress strain graphs are more useful as compared to force and extension graph. But the shape of the graph will be identical for both of them. Is it clear? Any doubt in this part? Is it clear for everyone? So we are done with the last topic of unit 1. So unit 1 of AS physics we completed. Some questions. Question number 1, material question. Question number 1, what is the right answer? The diagram shows a graph plotted using a results. What is the right answer for this? Yeah, D is the right answer. Because stress strain graph, the slope gradient represents the Young's modulus. The graph shows how the stress vary with the strain for a given material. Any given material is there? How the stress vary with strain? So we have to define these terms: limit of proportionality and tensile strength. So what is the limit of proportionality or proportionality limit? It means that that's the last point, stress proportional to strain or force proportional to extension. Up to this point. And what about the tensile strength? It is the greatest or the maximum stress. Yes, you can mention obeys Hooke's law. or the greatest stress or maximum stress before the object break, or when object break we use the term fracture. The yield point, what is the meaning of the yield point? Yield point, look, when very small change in stress produce a maximum strain. Here in this region, the change in stress is negligible as compared to the strain. So normally when the graph line is parallel to the strain axis or extension axis, that region is known as the yield point region. So what is the meaning of the yield point? So the term yield point is refers to that small change in stress, but we have a greater change in strain. Or you can also mention it is a point where the plastic deformation began, or we can also say that greater or larger increase in strain for small change in or increase in stress. That is called a yield point. Using a cross and the letter, mark a limit of proportionality and yield point. How to mark a limit of proportionality? You will use your ruler, the point where the line, last point where the line appear to be straight, that is a limit of proportionality. And yield point, when it is approximately parallel, the line, your line is parallel to strain axis, within that region you can mark anywhere as a yield point. So these are the questions we will discuss. Remaining question next class related to our topic materials. Any doubts related to the class today? So we completed the syllabus for unit 1. Next week we'll start unit 2 of ES physics. Any doubt related to the class? So I'll end the session and share the recording with you.